Welcome to the Vulcan Palletising HMI. This is a user-friendly graphical interface designed to work with virtually any industrial robot. The pick-and-place logic remains on the robot controller, which allows system integrators to easily adapt the solution to any application. We provide a basic palletizing program, but integrators are free to modify and customize it as needed. The robot controller and the HMI communicate over ModbusTCP. The HMI sends commands and parameters, and the robot responds with status feedback. This architecture provides greater flexibility compared to conventional palletizing solutions. The HMI focuses on fast setup, clear visualization, and easy operation. This is the main screen of the system. The system supports 2 pallet positions and 1 or 2 in-feed conveyors. When 2 conveyors are used, different pallet patterns can be assigned to each conveyor. Using the drop-down menu, you can select from previously saved pallet patterns. Pallet sizes are fully configurable, supporting standard formats such as Euro, UK, US Standard, ISO pallets, as well as custom sizes. On the main screen, you can define the level where palletizing should start, while the current palletizing position is also displayed. Boxes that have already been placed are highlighted in green. You can also see the slip sheet, conveyor, and pallet sensor signals here. The HMI can read their status from the Modbus registers of the robot. In the middle of the screen, you can see the current command the HMI sent and the status the robot replied. Below these, you can also control the gripper and monitor its feedback signals. Let's go and see the pattern page. The current pattern is automatically selected, but you can also load and edit others here. Don't forget to save your changes. The first step is to define the pick positions and the parameters of the gripper. Any custom gripper can be used. The HMI simply instructs the robot when to grip, while the gripping logic itself remains fully programmable in the robot controller. In the pick position section, you can define where the robot picks up the box. By pressing the first icon, you can enable the robot's hand guide mode so you can move it manually where it should be. The second icon records the robot's current position as the pick position. The third icon moves the robot to the stored position. If the box should not be picked from its center point, this can be adjusted in the last column by defining the offset from the gripper TCP. The pick position for slip sheets can also be defined the same way. The place position defines how far the placement point is offset from the pallet edge. By modifying the pallet offset parameters, the saved pallet pattern can be shifted accordingly. This is handy when you want to start packing on a special pallet. The HMI offers automatic pallet pattern optimization. You can define box width and length, minimum gaps, allowed overhang outside the pallet, and enforced overlaps. Patterns are automatically mirrored to improve load stability. You can later choose if you want to use both versions or just the basic one. If required, patterns can be edited manually by adding, moving, rotating, or deleting boxes directly on the screen. Any changes made here, such as deleting a box, are immediately reflected on the main screen. In the Layer Setup section, you can select the pattern used for each layer, offering maximum flexibility. You can also define under which layers you want to use slip sheets. All parameters and pallet patterns can be saved and loaded as recipes, enabling fast and efficient product changeovers. Any lifting column can also be integrated into the system. The HMI transmits target positions, while the robot program determines how and when the lifting column is used. The system supports operator and administrator user levels with fully customizable operator views. You can define whether operators have access to the pattern page, pattern go-to buttons, pattern free drive buttons, the manual page, the alarm page, or the Modbus page. Within the pallet limit settings, you can define constraints to prevent the robot from being sent to unreachable positions. Tool I/O labels can also be configured, and the assigned values are then displayed on the main screen. If you'd like to learn more or have needs not yet covered, get in touch.